Hello and welcome back to another session of Mentoring Maya. I'm Mohammed Bilal, and today, Maya and I are going to dive into something that is, truly, the bedrock of all clinical research, good clinical data management practices. We're talking about the essential rules and processes that make sure the data we collect is reliable, accurate, and completely trustworthy. So let's jump right in with the single most important idea at the heart of it all. You know, it all starts with this one powerful idea: trust. This quote from the Society for Clinical Data Management really just says it all, doesn't it? Every new medicine on the shelf depends on regulators, doctors, and you, the patients, trusting that the data behind it is solid. Without that trust, the entire system, well, it just falls apart. Our entire job in data management boils down to one thing: building and protecting that trust every single day. So today, we're going to walk through the entire life cycle of clinical data, and we'll do it in 4 key stages. First, we'll start with those foundational principles. Then, we'll talk about how we design a blueprint for quality data. After that, we'll get into the active process of keeping that data clean, and finally, we'll cover how we lock it all down and store it for the future. It's the whole journey from concept to archive. Okay, so before we even dream of collecting the first piece of data, we have to lay a really strong foundation. And this isn't about databases or forms yet. It's about the ethical and legal principles that protect the most important people in this whole process: the trial participants themselves. What's so critical to understand here is that these principles are totally non-negotiable. Every single person who participates in a trial has a fundamental right to know what's happening with their information and an absolute right to privacy. This means we only collect what is absolutely necessary, and we protect it like it's gold, whether it's a piece of paper in a locked cabinet or electronic data sitting behind a firewall. This right here, this is the cornerstone of trust. All right, so if protecting privacy is our foundation, what's next? Well, just like building a house, you need an architectural blueprint. You'd never start hammering nails without a detailed plan, right? The same thing goes for a clinical trial. A really solid plan ensures that every single piece of data has a purpose and a place. This structure is basically how we avoid chaos. Good data management follows this classic project management lifecycle. We define our goals, we plan out every little detail, we execute that plan, we're constantly monitoring to make sure we're on track, and then finally, we close the project out properly. This systematic approach is what ensures quality and consistency from the very start to the very end. And that brings us to maybe the most critical document in this entire process: the Data Management Plan, or the DMP. Think of this as the master guide for the entire study. It's the single source of truth that tells everyone, and I mean everyone, from the data manager to the site coordinator, exactly how data will be collected, handled, and stored. And let me be really clear about this. This plan must be drafted and approved before a single data point is collected. A poor DMP can literally doom a study with bad data before it even begins. All right, with our blueprint in hand, we can now move into the active construction and inspection phase. This is where data starts flowing in from all the clinical sites. And Maya, this is where so much of the day-to-day action happens. Our job isn't just to collect data, it's to actively police it, making sure everything that comes in is accurate, consistent, and clean. So, what happens when we find an error? Well, we have 2 main tools in our belt. For something really simple and obvious, like a clear misspelling on a paper form, an authorized data manager can make what's called a self-evident correction, as long as it's fully documented, of course. But for more complex problems, like say a lab value that just doesn't make logical sense, we issue a formal query, or a data clarification form. This sends the question right back to the site so they can investigate and efficiently correct or confirm the data. Now, this brings up a fantastic question from Maya. Imagine you've got one site reporting a headache, another one reports head pain, and a third one calls it cephalalgia. They all mean the exact same thing, but to a computer, they're completely different. So how do we handle that? The answer is medical coding dictionaries, like MedDraw for adverse events and WHO drug for medications. These are basically universal translators. They provide a standard set of terms, so no matter what words a site uses, we can code it to a single consistent concept. This is how we make sure that when we go to analyze the data, a headache is always a headache, no matter what it was called initially. Okay, we've built the house. We've made sure every part is up to code. Now it's time for the final stage: locking the doors, handing over the keys for analysis, and making sure those blueprints are stored safely for a very, very long time. Now, before a study is completely over, we might do something called an interim lock. It's like taking a snapshot of the data for a mid-study safety review. We freeze the data, analyze it, and then we unlock it to continue our work. But the final lock, or what's sometimes called a hard lock, that's permanent. Once that happens, all data entry and cleaning are finished. No more changes can be made. The database is officially ready for the final analysis.
But after that final lock, the story isn't over, not by a long shot. There are strict regulations, like ICH Good Clinical Practice and the US FDA's 21 CFR Part 11, that tell us exactly how we have to preserve or archive all the trial data and documentation. This is all to make sure that the entire trial can be fully reconstructed and audited years or even decades down the road.
So, how long do we have to keep all this data? What's the magic number? Well, the simple answer is 2 years, but it's a little more specific than that. According to ICH GCP guidelines, it's a minimum of 2 years after the final drug approval or after the project is officially shut down. That's the baseline to ensure long-term accountability.
This is such a critical question. I mean, think about it. The software we're using today might be completely obsolete in 10 or 20 years. So how can we possibly guarantee that future auditors or researchers can actually open and read the files we archive today?
The solution is to avoid trapping our data in a specific proprietary software format that might just disappear one day. Instead, we use what are called open, non-proprietary formats. These are like universal file types that are designed for long-term accessibility and don't depend on one specific company's software to be read.
And here are some real-world examples of these future-proof formats. We might save electronic case report forms as PDFs. The raw data itself could be stored in a really flexible format like XML, or in a widely accepted statistical format like SAS transport files. Using these standards is what ensures the invaluable data from our trial will stay accessible and readable for decades to come.
So there you have it. We've journeyed through the entire data lifecycle, from the foundational ethics of trust to building a blueprint, cleaning the data, and finally to locking and archiving it. Every single one of these practices is designed to uphold that central principle, ensuring complete confidence in the results. And that brings our journey full circle. I hope this has been a helpful session in our Mentoring Maya series. And I'll leave you with this final thought to chew on. As things like artificial intelligence, wearable sensors, and all sorts of new technologies change how we collect data, the fundamental challenge is still the same. How will we apply these timeless principles of privacy, quality, and integrity to the tools of tomorrow? It's a question we all need to be thinking about. Thanks for joining us.